Now it's not working, obviously. So now, welcome to the Rook talk about running Ceph in Kubernetes. I'm Alexander. My colleague isn't here, Sahm. He's getting old. His back is hurting already, but he's sending his greetings. But there's one more, well, not technically a person, but Sir redundancy. And yes, well, the Sir is redundant. He's the mascot of the Rook project, and he will kind of also follow us through the presentation today. For the agenda, we have what is Rook, the architecture, so not only you know that it's doing something with storage or also something with Ceph. We have, as the most important part, the Kubernetes integration. Otherwise, well, Rook wouldn't exist if it wouldn't be about Kubernetes there again, kind of. We have a special part for Ceph with the configuration. How do we tell Rook there to, for example, use specific disks or so? On the other hand, we also have the point that just for a Rook project in itself, there's more than just Ceph in it. And then at the end, a demo about deploying a Ceph cluster in Kubernetes. And yeah, let's get right into it. So what is Rook? Rook is, well, as is for Kubernetes, it should probably be cloud native. So yeah, it is cloud native. It is a framework to, well, run storage backends, not only like something like Ceph, which we come back later to, but also things like Cassandra, like in general persistence. So Rook in itself is not only about just running big storage software like Ceph. It's in general about providing a persistence layer. But as we are at Cephalicon, Ceph is the most interesting part here. Besides that, for Kubernetes side, we utilize what the Kubernetes API is giving us as, well, even for infrastructure especially, it is cool to have simply an API we can talk to and in the end get an end result. We'll go into that later on in the Kubernetes native integration part there. We also have the part where by running the whole components of a Ceph cluster inside of Kubernetes as containers, we can simply go ahead and update them, change them as we need, and spawn new ones if we need. Another part is that, as already said, with Rook not only being for Ceph, Rook in itself tries to be a framework. For example, maybe you have heard about the company Nexenta. They have the project EdgeFS, which is, well, kind of also like Ceph in that regard. It's also a storage backend where we also have block storage and also file system storage. And the point there being that we have some common types that you have that you have it easier to move from one to the other if you wanted to. But in general, that there's one common type which you can use to specify a disk to be used with Ceph, EdgeFS, or well, any other coming storage backend. More or less on the part with, does it cost anything? No, it is open source. It is licensed under the Apache 2.0. And well, go for it, use it. Besides it being open source there, we are thankful to the CNCF for hosting the project right now as, incubator? Incubator, yeah. And yeah, so you will, if you should be at KubeCon, we'll probably also hear one or two talks about Rook there. This point isn't on the list, as it is more or less, throw in. Maybe as a question to you guys, who has heard about CSI? Like, well, not the police force, but like CSI container storage interface. Okay, yeah. CSI is to keep it simple for those that don't know yet, is, well, an interface / API, if you will, so where it's kind of a try to, well, not a try, it's pretty successful from my perspective, to have one way to request storage, to just your application goes to it, or especially in that regard, Kubernetes will talk with these CSI drivers in the end, and be able to, no matter what storage it is, be it Ceph, be it, I don't know, like NetApp stuff, or an NFS server that has this API implemented, you can just go to it and say, hey, I want storage, with some, well, obviously some more parameters in the end, but you will get storage in the end there. So this makes it pretty easy to have storage for your applications. And one point to note for the CSI part there, it is not just like for Kubernetes. Good, it's more or less focused for containerization because of the container storage interface, or well, the container in the name. But, well, you can in the end probably use it for anything you want, but you would need to request storage. Under the CSI as a future, there's the flex volume still exists. Before CSI, going back in history there, the flex volume was kind of the, I would say, temporary way of having something like CSI. Like, well, it's basically in the end almost the same thing, but from perspective or from feature and usage field more or less focused on Kubernetes. So why am I putting this up here? Right now, Rook can, or by default, will use flex volume, but will already has with 1.0 has the option to deploy with CSI. That will more and more be moved. I think in like 1 or 2 versions it should be planned that we move CSI to the default way and slowly fade out the flex volume way to have one interface there. And well, as kind of the work for the CSI driver there that does the mounting and everything is moved to, well, to the storage projects themselves, it's kind of a bit less work on our side. And as the CSI driver, as I said, it's not only for like Rook in the end, it's for everyone that would also normally just want to mount some storage from Ceph. So double the advantage there. The architecture. For that, I have my pointer. From a Kubernetes side, especially here, like I'm not showing too much of the Ceph cluster components there, but we'll get there at the daemons part there. It may look a bit complicated. It also is a bit complicated. It's not just looking, but just from an outsider's perspective there, you have your kubectl tool, which, well, simply allows you to interact with the Kubernetes API. And as Rook brings in custom types, this means that you as a user, if you want a new storage pool in your Ceph cluster, it's not a problem. You create in Kubernetes, you create a new Ceph block volume block pool object, and then a new pool is spawned, is created into in the Ceph cluster. If you want the volume for your application, we have a small example of that later on too. You would normally just use the process of how Kubernetes does it with so-called persistent volume claims. But again, there, the input path is basically through the kubectl, the client tool there, which does, well, which talks with the Kubernetes API. Then we also have the Kubernetes API, consisting of a bit more than one component if you want to know it for exact. But in the end, moving on to the more right part there, we have our nodes. They are running kubelet, which is the node component. And you probably also have disks in the servers. And right now, as it is with flex volume, but also with CSI, you have, well, the Rook flex volume or the Ceph CSI part there on the nodes. From Rook's side, to make it easily possible for us to kind of orchestrate the whole thing, as you may remember from the keynote from Sage in the beginning, talking about the manager with the orchestration there, and you may have already heard Rook there. You can, from a technical standpoint already right now, well, we're still working on it, making it really like this from the feeling. Right now it would be like you create a cluster, I'm going into that later how we do that, and Rook will take care of creating everything. But in the end, it's more thought that like you create such a cluster, but you don't get any OSDs or so. You just get your mons, your manager as you need, and then you go to the dashboard. Well, if you want, you go to the dashboard then, and can then click by click say, hey, please create an OSD. And then Rook, because it's running in Kubernetes, will just spawn the containers on the right machines there and use those disks for the cluster. Right now, it's, well, you can have it with this too, but there are some restrictions right now. But we're working on getting the integration there even further and even more improved. The Rook Discover pod, which should run on every node where you have disks that you want to use, is the part that, well, as the name implies, discovers the disks on the machines. And the information on what disks are in each node is used by, well, in the future also completely in the dashboard, that you can see what is going on, what disks are available, which disks do I want to use. But you also have the possibility, with the information from that, the operator can specifically, based on that, create the OSDs already, as it is right now. And then in the end, I said with the manager too. The Rook agent is right now the flex volume part there. This would in the future be just a CSI component which takes care of the, well, mounting, mapping, and so on of the storage that you want to use from Ceph. But also on the nodes, you will obviously will also have like maybe a mon or an OSD or so. You can tell Rook where it should place those components. But for OSDs, it would make most sense if you put it there, well, where the disks are. Otherwise, well, you won't have too much fun. Yeah. So that's the architecture of Rook in itself. Pretty Kubernetes heavy there, but if you have someone, to put it like that, if you have someone that can run you the Kubernetes cluster, it is doable. It is definitely doable. Simply also because of those custom objects where you can specify what is going on, or the team that runs the cluster for you. That's where we come to the Kubernetes native integration, starting there with the with getting a block storage pool, or well, a pool in Ceph created. This is what you create in Kubernetes. You create a 8-line object in Kubernetes, and based on that, the Rook operator, which is watching for those objects, also for changes on those objects, goes ahead, runs, what was it, Ceph OSD create pool or something? I've done it too many times using Rook, so I don't know the command in full right now. But the Rook operator talks with the Ceph cluster in the Kubernetes cluster. We're working on having it with an external cluster too, thanks to Travis. But you create this object. With that, we would get a replicated pool by size 3. Some are probably saying, where's like stuff like min size and so on. We're working on getting more parameters available there. I think device class has just been merged also in master, yeah. So we have already some new stuff coming up after the 1.0 release. But even if you wanted erasure coded, you could just say erasure coded and then data and the parameters for it. Continuing on with this example, in Kubernetes to be able to consume the storage, I need to create a storage class. A storage class is, if you look at it a bit, you may already kind of see what it's basically. It's kind of just a holder of parameters. It has like information which block pool to use, which cluster namespace, which, well, results basically in the end to the cluster name, which, well, depends on the namespace you're deploying the cluster in. You have the file system type, where you can say, yeah, do it XFS or X4 on the block devices that are getting created there and, well, in the end, then mounted. And this contains the information the operator then again also needs to create block devices, in this case, in the Ceph cluster. Because if I'm a user, in the end, or well, yeah, I'm creating a so-called persistent volume claim object. You see it here? We even tell it like which storage class it should use. You can set them as default as a hint there, but in itself we set it here. We tell what access modes we want. That is important, as block storage, mounting it at multiple location read-write is, well, we have Cephfs, am I right? And we say, hey, make it 20 gigabytes big. And if we would create all those three objects, and we already have a Ceph cluster existing in the Kubernetes, what would result out of that? Storage for the application of size 20 gigabytes. And bam, your application has the storage now. And, well, to come back to Cursor redundancy, he slashed through the integration part for the application there. Yeah. Coming to configuring Ceph. For Ceph, there is a so-called Ceph cluster object that the Rook operator brings with itself. And this is just a snippet of what you have as options. But parts of those options are, yeah, well, use all nodes. You can even then above that say which nodes of the Kubernetes cluster it should use. Like some which have a cool label like big storage is true as a label, for example. And you would say in the top of this object only use nodes for OSDs which have the label big disks, for example. Or even something like use all devices, where it would go through the list of devices on the server and use all devices, but only devices which are empty. So don't worry, your SDA with your OS or something on it won't be deleted. You can even have a device filter for that again. You can say something like SDB and say, but SDC2, like with a regex, basically. We have location, which was the crush tree location, the crush tree map, the crush map location. And, well, after that, we even have some more options, which we're diving into directly now. We have, well, it's already the default to use BlueStore, at least for devices. But you can say, well, I need file store for whatever reason, so, well, set it to file store if you want. You can specify a metadata device. You can specify how big database journal size and so on is. For example, for NVMe, you want more than one OSD. You can also specify that. You can also say that it should be encrypted using dmcrypt, was that right? dmcrypt, yeah. So it's there, basically. An important part about those configuration options is that if I go back one slide there, the intention is when the config should be one more to the left, but you have this part, this is a cluster-wide setting. So if you would set something there, it's cluster-wide. But you can also, if we're going further now, you can also specify a detailed list per node, basically overriding these cluster-wide settings. So that, for example, you have normally the same nodes in a cluster, but then someone, well, has some special nodes, and you could just add them there as in a node list as a separate part. As we are in containers, we can limit and, well, request memory and CPU that we want to have for the components. Those wouldn't be too good of values depending on the size of the disks. But yeah, so you have the settings on a cluster-wide, but also on a node level in the end. Here, for example, for a node with like an NVMe device, where you want to have 5 OSDs for this device, but also like a device filter where you want to use all SD devices. And, well, it's YAML in the end, so it's at least a bit human readable in the end. So again, with these YAMLs that we have there, we kind of can go to the treasure there. We just create them and we already have Ceph class. Isn't it cool? So we have a treasure chest already in Ceph there to store the data directly of the applications. So, coming up is the demo now. So, okay, let me just double check. Perfect. So, what I'm going to show now is I have a 3-node Kubernetes cluster, which all of the nodes have one 200 gig disk attached, and well, let's create a Ceph cluster. And well, besides creating the operator in the cluster, which, have I done that? I hope so. Let us check. No, I have not done that. Just a second. So what I'm doing right now is navigating to the repository of Rook and going to create in, well, it's 3 steps, I think, actually. I think someone created a PR to update the number of steps. We had it at like 2 steps, but after some refactoring to make the examples easier, it was then, well, 3. So we create the first one, which what you're seeing here right now for the people that haven't worked with Kubernetes yet is basically just me telling with kubectl to take the YAML I pointed it to and run it against the Kubernetes API and create the objects in this YAML. And we do that for the second one as well. So, to give you an insight on what we have right now, let me make it a bit smaller. I hope you can see it well. What we have right now, we just have the Rook Ceph operator, just a component which takes care of, well, if it sees those objects which we talked about earlier, do something, create objects in Kubernetes, like create monitor pods, or well, monitor containers and so on. And now it has even created those other components that if you remember back at the architecture, we had like discover and agent. So it's also going ahead and creating those objects. And we can already go ahead, go back to the actual example folder. And what we have here is a cluster YAML. If I'm able to open it now. To just again, what we saw previously, it's a bit more than that because, well, there's a bit more than just telling Ceph what disks it should use from Kubernetes side. You have also stuff like what network it should use in Kubernetes. If you want to especially put some resource limits, also again cluster-wide on the components created by the Rook operator. But also stuff like, should the dashboard be enabled? There's also an option to disable the SSL of the dashboard. And again, it's a pretty simple one. It's just for the nodes, perfectly fine right now. So what we're going to do is just double check again. Everything's running. That is good. And we're going to deploy the cluster. And you can see it. Well, besides the other objects previously for the other two YAMLs we created, to create a Ceph cluster, even with a sophisticated configuration with multiple nodes or 10, 20 something, or even 100,000 nodes or so, it would be just one object in the end for Kubernetes. So as we see, we have created a Ceph cluster called Rook Ceph. So if we go ahead and look into that now, so to shortly, while it's taking a bit of time, and servers that I'm using are not having the best reception, the best bandwidth to the Docker Hub registry. What is basically happening when you create such a cluster object? The operator will spawn a container where it starts the image that is specified in the Ceph cluster YAML. If you look here, you can specify what Ceph version you want. That's especially important as we decoupled that with 0.9 or 0.9. Yeah, with 0.9 release. You can specify whatever Ceph image you want in the end, but well, Rook can only support what it supports, as there are sometimes some slight changes of the Ceph CLI command. Where is it? Yeah, so it's taking this image that you specified and starts one container to just make sure what version it is. This is kind of just like a safety measure there, as not all images at the end of that you specify there would have a semantic version pattern like v13.2 and so on. And after that, perfect, we have mons now. What the operator then does is create the first monitor, wait for it to start, to have formed quorum, start the next monitor, wait for them to have formed, quorum again, you need 3 to have it in a good way. And now it's basically initializing the third monitor, which is the mon-c. Now it has created a third one. Now, it takes a bit of time till, not much, but a few seconds for the monitors to form the actual quorum there in the end, or also for the operator to do certain things after that, which we, for example, are now already at a stage at having a Ceph manager running, which, it's still creating the container in the Kubernetes cluster or the pod, but now we have it. As we saw in the cluster YAML, like those dashboard options, we only saw like the is it enabled or not. Those options are, for example, now done by the operator. Now it's waiting for the manager to be ready to take those options, configure it with the Ceph CLI, and after that, perfect, we already now one further. And after it has set up the manager with that, it will right now, as it is, create so-called Ceph OSD prepare pods. What those do? They prepare OSDs. They take the information that has been gathered by the Rook Discover, and which has orchestrated, has been kind of made, into a map, if you will, so by the operator. And based on that, these jobs run. Maybe it's a bit. We already have some OSDs. We have the 3 OSDs, yep, perfect. And now, after those prepared jobs is run, they take the disk then, or what the directories that you want to use, prepare them to be in Ceph OSD. And, there we have it. We have 3 OSDs. But to make this more visible, as we all love to see it also from a Ceph-S perspective, let me quickly jump into the toolbox. Is it running already? Yeah, it is running already. There we go. We have 3 worker nodes in this case, or well, 3 servers. We have the Ceph-S, it's healthy. Well, we haven't created a pool yet, but we can do it in a second. And Ceph OSD tree output is also looking good. We have the 3 OSDs up and running. And even now, if we would just go to, where is the file? To this wonderful YAML, we have, looking at above the first part, at the top part, we have again a Ceph block pool object, which we shortly had it with this storage example. And well, basically those 2 examples we had there are combined. We say, please create a pool named replica pool with a size of 3, and the storage class again where it references this Ceph block pool and the namespace of the cluster. So if we go ahead and create that, to then go into the toolbox, as we call it, the Ceph toolbox, run Ceph-S, and there we go. It's, well, still creating partially. Let's see, is perfect, active and clean. We now have created 1 pool with, well, 1 object in Kubernetes. And to go further on that, we had it about those persistent volume claim objects in Kubernetes. I hope it's visible enough for you guys, but this is just again the example from previously. We tell it what storage class it should use. We say, hey, we want 20 gigs of storage. So let's create it. And if I'm now hopping into the toolbox again, replica pool, there we have it. The application could now go ahead in Kubernetes, say, hey, I want you to use this claim of storage, and it would start and get the storage mounted. Yeah. So let me switch back. There we go. This one. So maybe just one more note there. Servers are from in the Headster cloud using their volumes storage they have. It was 3 nodes in the end, and from server type CX31 from the cloud offer. Yeah, so we have mostly heard about Ceph right now, but Rook is more than Ceph. Just more or less as a side note there. Rook has, for example, as we had like the Rook Ceph operator, but if you wanted to run HFS from the Nexenter guys, you would have a Rook HFS operator. If you want to run Cassandra or Mina, you would have a, well, then Rook Cassandra operator and so on. So it's not like you deploy Rook and you have everything. It's split that exactly the people that want Ceph can have their Ceph stuff as they want it. And people that would want to run Cassandra can run their Cassandra operator. Or even combine it then with a Rook Ceph operator to have a cluster for storage there. Yeah. And there a big mention to the community behind Rook 2. That thanks to them, even also for the Ceph part, not only for the Ceph part, with the great work going on, with as we had it like the device class finally coming to those block pool objects. That was done thanks to the community. So we can only do it together. And to get involved, if you want to check it out, also go to the GitHub. We just had an awesome site redesign. You'll love it, the site redesign. If you want to contribute, go to GitHub. We also have a Slack, especially for conferences, like the hashtag conferences channel there. We are on Twitter. We have a mailing list too. And we have like a bi-weekly community meeting. if you want to, well, bring something up to the community there. And yeah, again, a big thanks to the community. As well, yeah, without the community, we wouldn't be as far as we are right now. Already questions? Does anyone have a question? Do we have a microphone? Migrate an existing Ceph cluster to Rook? You can. I have played around with. You can do it. It's more or less due to the fact that the Rook Ceph operator initializes everything for you. If it would have like an option to, like the monitors, not initialize them completely, then you could start the first one, add it to your existing cluster, start the next one, but Rook Ceph isn't too much into that direction. Yeah, well. Any other questions?
Thank you for your presentation. I have a question. Do we need Ceph Rook agents if we are using Ceph only to provision storage and consumers are coming outside of Kubernetes Cloud?
Can the consumers of storage of a Rook Ceph cluster be outside, right?
Yeah.
Yeah. Yes, it's you're kind of, well, with that obviously you're kind of losing out on the fact that if a monitor fails in Kubernetes, like the node on which a monitor fails. Right now what Rook would do is spin up a new monitor on a new node basically, and with that have a failover, if you will so. If you're able to keep up the nodes that mount the storage, if they would at one point really completely unmount the storage, update it with this list or use some way with load balancing or so there, then yeah, it is possible. There are people that use it especially for Cephfs. But I think there are even people for block storage, I think. Or, yeah, outside, yeah. Yeah, we hear about people using that already like that. But there's one specific part you would need to watch out for, is you would need to use the host network option on true. Because otherwise, as it's in Kubernetes like capsuled into a SDN, well, you wouldn't be able to reach the Ceph components. But with host network, you would then just use the host network stack.
Yes, we are using host networking. So yeah, we and our consumers outside of Kubernetes cluster. And yeah, it is. I'm not sure that why we need to run a Ceph for a Rook agent inside. So it's kind of like looks like not needed when you're consuming block storage outside.
Yeah, well, right now you can disable where they run, so you would just keep them running. It shouldn't be any harm done if you just keep them running. So, well.
Okay, no. Thank you.
At the back there was a question. Good. Do you want to sprint? I can sprint too. Oh. I'll take it. So.
Do you support any kind of auto scaling of MDSs or Rados gateways, and what are the metrics like? Can you put custom Ceph metrics there?
Right now not, but you could, just from Kubernetes perspective, create a so-called HPA, a horizontal pod autoscaler, which would then, based on a metric, scale it up. But I think more and more looking into like the Ceph manager orchestrator part there, this would basically be the way to go. That the manager would see that and then orchestrate, as it's a generic interface there, that there is a need for more MDSs. So should be possible, yeah. Other questions? If not, I'm here the whole day till like, well, even at the KubeCon. So yeah.
Maybe I'll just make a comment too about related features coming up. So in the 1.1 release for Rook, looking at connecting external Ceph clusters. So for example, if you've got Kubernetes running here and you've already got an existing Ceph cluster over there, you want to connect your Kubernetes pods to that storage that already exists. So we want to make that simplified so it doesn't require extra manual steps to get that working. So connecting to external storage clusters is part of that. For example, getting the CSI driver to be aware of the external cluster, connect to that storage.
Chris. And well, if you, after the talk now, have any questions, I think you should be able to find me. And well, if you want some stickers, at the Upbound Rook booth, there's also the flag on the table there. So if you want some stickers, or even have some question, I'm probably being around that booth. So yeah.